Hi class, this is Stan, first year instructor, and we're getting ready to introduce the next unit, volume 9. So let's turn this around and turn this camera around, and we'll take a look at the slides that we have, okay? Okay, this is unit 9, volume. Okay, it's part of the geometry sequence. So let's just move on through this, okay? Our objectives here, we're going to identify the parts of a cylinder, a cone, and a sphere. We're going to connect the volume of all three of those. Cylinders, cones, spheres is an interesting connection. And like I told you in other places and times, that mathematics is there is a portion of it that's calculation, but the really important stuff is the connections you draw between different things. Because those connections apply universally. Okay, and then we're going to apply the formulas we find to find the volume of a cone, a cylinder, and a sphere. Okay, these are the things that you need to know in order to get the most out of this unit. Okay, you're expected to have mastered addition, subtraction, multiplication, and division. Okay, if not, then I'm going to provide some links for you in the description, and hopefully you can address that quickly. Okay, here's the other thing: circles. You need to know what the radius of a circle is, the diameter, circumference, and the area. You're expected to know these things, and again, we can work on that if you don't. All right. Powers, bases, and exponents. We covered that earlier in the year. Again, those are things that you're going to need to know. And solving one-step equations. I told you that solving linear equations was never going to go away. Yep, it's back. You need to know these things, okay? Now, like I said, I'm going to provide links. If you need a refresher, look for the links in the description. Okay? Self-checks. One of the most important parts of learning any skill is learning enough to be able to self-correct. Okay, so here's a couple of suggestions. Come up with your own. Talk to me about your own self-checks, things that you can do that say, hey, look, I know this answer isn't right, and here's why. Okay, so for a circle, the circumference is bigger than the diameter, and the diameter is bigger than the radius. So once you have it down that what the circumference is, the diameter, and the radius, let's say I give you a radius of X amount, like 5 units, and then I ask you what the diameter is. Well, you know that diameter is going to be bigger than that 5 units. So however you go about calculating that, okay, it's got to be bigger than that. But it's got to be smaller than the circumference, okay? So if you come up with 3 of these numbers, the circumference, diameter, and the radius, and the circumference is the smallest of the 3, then you know something went wrong somewhere, okay? Okay, corresponding volumes. We're going to find out that the cylinder is, for a cylinder of some base and height, a sphere with that same height and that same circular base through its equator is going to have a smaller volume. That sphere is going to fit inside that cylinder, okay? And the smallest of all is going to be the volume of a cone of the same base and height. Okay, so again, if you calculate the volume of the cylinder, it happens to be smaller than the volume of the cone. Again, you know something went wrong. Okay, powers. B to the n. That means the some base to the nth power is b times itself n times. What it is not is b times n. Okay, check yourself on that. I still see people doing 3 to the 4th power and telling me that it's they're multiplying the base and the exponent rather than 3 times 3 times 3 times 3. Okay, so let's keep going. All right, again, we're introducing this stuff. We're going to get into the specifics later, get you started, but we're going to ask ourselves, is there a relationship between the volumes of a cylinder, a cone, and a sphere? I'm going to have you watch this video. Pause this video, go watch this one that you see the link for, and it'll be in the description as well. But then come back and then see if you can describe it. There's no words in this video, so you're going to have to come back. Now I'm going to pause the video, and then when I start talking again, I'm going to assume that you've come back, okay? Pause now. Okay. So this is a video you just watched, okay? If you see this, you're going to see that that there's a sphere here. That sphere would fit exactly inside that cylinder. That cone has the same base as that cylinder and the same height. And you found out that it takes 3 of those cones to fill that cylinder up. Okay, and so that cone has a volume that's 1/3 of the cylinder. We don't know yet how to calculate the volume of the cylinder, but we know that if we're going to fill that cylinder up, we're going to need 3 cones of whatever material it is. And then the sphere, now, I wonder why that is. You know, it's like, well, why on earth would the cone be 1/3 and the sphere just so happen to be 2/3? Because, you know, you'd think, hey, the volume of a sphere and a cone of some particular base is going to equal this volume of this sphere, this cylinder. And that's just, well, I mean, it's kind of odd when you think about it. But there should be a reason for it, okay? So, let's talk about it. Is there a relationship? Yes, and you just saw that, okay? We know that the volume of the cylinder, we don't have some form we don't know yet, and we'll learn it in the next video. The volume of the cone, it's 1/3 the volume of the cylinder. Okay, it takes 3 of those cones to fill that cylinder up. Volume of the sphere, 2/3 of the volume of the cylinder. And what this means is that when we finally get the volume of the formula for the volume of the cylinder, we've got half the battle. We've got half the battle for the rest of the module. So all we have to do is when we go to cones is just remember to divide by 3. We get just by multiply by 2/3. Okay, here's your example in checkpoint. You have a cylinder with a volume of 600 cubic centimeters. What's the volume of a cone with the same base and height? Well, 1/3 of 600, or 600 divided by 3, is only 200 cubic centimeters. Okay, and that's your answer. Okay, you have a cylinder with a volume of 600 cubic centimeters. What is the volume of a sphere that has the same radius and height? Well, we take that volume of the cylinder and we multiply it by 2/3. We already know what 1/3 of 600 is. That's 200. And then we multiply it by 2. That 200 becomes 400 cubic centimeters. Okay. Okay, your turn. You have a cylinder with a volume of 1,800 cubic centimeters. What's the volume of the corresponding cone and sphere? Okay. You can pause that and try to figure that out, but we're going to move on, and I'm going to give you the answer later in the video. Okay, so what comes next? We're going to do the introduction to and applications of the cylinder. That's 2 modules within your Edgenuity course. Okay, we're going to do an introduction to cones and spheres. Okay, basically show you how the cones and spheres differ from cylinders, and then we're going to do applications of cones and spheres. After that, it's a unit test. All right, and then we're going to move on to our next unit after that. So let's take a look here. Answer, we're going to come back to the self-check. Okay, you had the cylinder of 1,800 cubic centimeters. What's the volume of the corresponding cone and sphere? Well, the sphere is 2/3 of the given value. So divided by 3 times 2 gives us 1,200 cubic centimeters. The cone is 1/3. We just divide by 3 and we end up with 600 cubic centimeters. Okay. Good luck to everybody, and if you have questions, please ask them, and I'll do my best to get back to you on those, okay?